welcome. In this video I want to just show you how you can use my empty game engine here to animate a sprite sheet. And I went out looking for some sprite sheets and I found this sprite sheet from an old Sailor Moon game that I thought was kind of cool. And so, this was one I chose not to use because it did not have transparent background, but this one I found had transparent background. And I'm not going to animate the whole thing because there's a lot of animations on here, although this would be great for a particular game. I'm just going to try and animate her walking animation, which I believe is this top one up here. And so I'm going to actually start by just grabbing it and cutting it out. This whole sheet is pretty big, and I'm going to just cut it down. So I've loaded it into Paint 3D, and I recommend using Paint 3D instead of Paint, because Paint 3D you can actually save it with a transparent background, but with Paint you cannot. And so what I want to do is a crop. Guess I need to grab my bottom one here. I probably don't need that first image there. I don't really know where I need to cut it off on the right there. Maybe it looks like this might be an idle frame and then the walking frame. So I'm going to cut off that first frame too. Maybe leave a little extra buffer there just in case. Hopefully whoever made this sprite sheet put an appropriate spacing between them all. Maybe I'll leave a little bit of space on that side too. 109 pixels, that doesn't sound right. Let's go one shorter, 108. So I'm just checking the numbers over here. Maybe add one more. Just that looks more likely what it might be. 108 sounds right. So I'm going to say done. And let's save. All right, now that I've done that, I am actually going to load it up into Paint. I'm not going to save it when I'm in Paint because that's the dangerous bit. But if you load it up when you're in Paint, maybe I'll zoom in a little bit. If you hover over the pixels with your little cursor here in the bottom left-hand corner, it will tell you what pixel you're on. And that might be useful for us when I want to know where my frames start and end, how wide they are, etc. Usually I use Paint for that. Just be careful not to press save. If you press save, when you close it, you don't want to save it, or else it will overwrite that transparency. All right, so if you want to get started like I'm doing here, I just downloaded that code and I just slipped it into a directory here that I'm calling animation demo, and then I dropped in that Sailor Moon PNG as well so we can access it. And I've loaded everything up into my Visual Studios, which is what I use to develop. And the very first thing I want to do is load the Sailor Moon image in. And I've got my asset manager here, so I will load that in. So to do that, I'm going to use my asset manager's queue download method to the queue a download. And we see here it takes a path. So we need to pass in the path of the file that we're going to be looking for. And since I just dropped that into the same directory that I'm in, I'm just going to do a // and it was called sailormoon.png. So now I'm going to make a new file. I just made a copy of main quickly here. I'm going to call this Sailor Moon. And load Sailor Moon in here. Don't need that. Instead, I'm going to make a new class, Sailor Moon. So all we're really going to need to build into Sailor Moon to get her to work is a constructor that we'll use to build her, an update, and a draw. And our draw usually takes the context that we want to draw to. So what I'll actually do is I'm just going to build in a very simple draw method here that just draws. Well, I need to tell it where it's going to draw, don't I? So it just draws the image. That's the whole image, not a frame, just the whole thing, to test, see, make sure everything's working. And the only thing I need to do is I need to make a Sailor Moon. No, I haven't made a Sailor Moon, so I'm going to go back here. I'm going to do a game engine dot add entity new Sailor Moon. And that will ensure that we've put a Sailor Moon into the game engine so that her update and draw gets called. All right, so I pressed run, I reloaded to try and see if this was going to work, and I actually got an error. And if you're kind of newish to JavaScript, this might be an error you get too. I forgot to do something. Let's see if we can decipher this error. When it gets here, it says, hey, there's no Sailor Moon. Sailor Moon's not defined. And we might say, wait a second. I did define Sailor Moon right here in this file, but what we forgot to do was tell the index to load that file. So I'm going to load that file. I'm going to maybe, let's see, this should be loaded in order of importance. So if something relies on something else, for instance, that main, which was sending us an error, said I need to know Sailor Moon, and that means we need to load Sailor Moon in before she's needed in the main. So let's try that. And we can see here that, oh, look, it worked. Okay, so at least so far so good. We downloaded the Sailor Moon sprite sheet, and we made a Sailor Moon object, and we loaded the sprite sheet into the object, but now all we need to do is animate that sprite sheet somehow. So I'm going to make another object here. Instead of another Sailor Moon, I'm just going to make an animator object. And you may have seen an animator in some of my other videos, but I'm just going to make a brand new one. And let's throw it in here. So I'm going to start with just a very simple animator. This is one that I really just copied the one I had from Mario, and then I just deleted out all the code because I wanted to make it a little bit simpler. But you can see the ones that I'm keeping are the current frame, which doesn't really change anything. The elapsed time, I haven't defined what elapsed time is, but take the elapsed time, divide it by the frame duration, and that should give you what the current frame is. And then is done, as long as the elapsed time is greater than or equal to the total time, we're good. So the first thing we need to do is decide what we're going to do with these parameters. Let's make sure we know what they are. The sprite sheet, that's pretty self-explanatory. The animator is going to animate one animation, so it wants to know where it starts. Where does the frame start? The X and the Y of the frame starting. The width and the height of the frame, that's going to be important for our calls. How many frames? And how long do we want the frames to be on the screen? So I'm just going to do an object.assign, which, remember, all this is going to do for us is copy down all of the parameters into our object. And when I do that, I usually just like that. But I haven't defined two of the things I actually need. I need elapsed time. That wasn't one of my things. So let's do that. This dot elapsed. And then we will also set up a total time. And that's just calculated from the frame count multiplied by the frame duration. And once we have that, we're pretty much ready to go. We just need to build our Drawframe method, which is going to go into our sprite sheet and select which frame we want to draw of our animation. So what we're trying to build is this draw image call, where what we're going to draw is this .sprite and then we're going to have to say this is where the source X and the source Y come in. That's I'm just sort of writing out the prototype right now. The source X and source Y are where on the sprite sheet we want to draw from. Then we're going to have the source width and the source height. How big of a frame are we grabbing from that? Then we will get the destination X and the destination Y, where we want to draw it on the canvas, and then we'll get the destination width and the destination height, how big we want to draw that as well. So these are all the variables we want to put in there. I've just got them sort of arranged like this so that I can arrange them easier in my mind, and then I can think what do I know and what do I need to calculate? So the destination X and the destination y are actually just the x and the y that are going to be given to us. So when the animator gets called, it gets called with the current tick, how long it's been, it gets called with the context to draw to, and then it gets called with the x and the y, where we want to draw it. In fact, I don't need this scale. That was a holdover from my earlier one, so I'm going to delete that. Instead, or I forgot, I need my CTX here. That's one of the objects I get passed in. That's telling me where I'm going to draw. And I'm going to draw in that context, in that canvas, and then I need to know this various information. As I mentioned, this is going to be an x, and this is going to be a y. Okay, the destination xy is just what was passed in. Now what about the width and the heights? Well, the width and the height, as long as we're not changing the scale of Sailor Moon, the width and the height is going to be given to us up above here by the width and the height. And for the moment, I'm going to use the same width and height that I'm drawing. So I'm drawing the same size that I'm fetching it. And if you want to resize, that's something else that we could do. But for the moment, I'm going to leave it like that. So the only thing we really need to know are what are the SX and what are the SY? Well, at least that image that we had drawn is all on one row. So we need to know the source X and source Y. And I'm going to guess for the moment it's 0. I don't think I'm right with that because I put a little bit of padding of white space on the front there. So I don't think it's 0, so I might be wrong here. And then I should be good to go. I'm probably going to have to come back in here. Oh, sorry, I said 0 and 0. That's what I want to do on the call, but here on my actual function, I should use the variables that I actually passed in. So that was a mistake there. X start, I obviously passed these in. What I meant to say is when I build this, I will pass in 0, 0 to start. Okay, so that's the start, that's the Y. But if we do this, X start and X and Y start, we'll only ever draw, this will only ever draw the first frame. And we don't want to draw only the first frame. So we want to figure out what frame we're going to be on. So let's do a constant, we'll call it frame, and we'll make it equal to the current frame. Now again, that will return the current frame, but if we do a quick check, we see what does it do? It takes the elapsed time, it divides it by the frame duration, and then it returns the floor of that, so it's going to turn that into an integer for us. But if we never change the elapsed time, remember we initialized the elapsed time to 0, if we never change that, then it's only still going to give us the first frame. So that's the last bit we need to do here. This dot elapsed time plus equals tick. And now let's make sure that this kind of makes sense. When we call this in, we're going to tell it how long it's been since the last time we called it. We're going to take that tick duration, add it to our elapsed time, use that to calculate what frame to draw, and then we're going to draw that frame with those calculated values down below. Well, we haven't actually added that frame calculation in there, but we're going to need to add that in here. And then how does that come in? Let's see. So if the first frame is going to be starting at X start, and remember all of our frames are in a row, not a column, in a row, so the X changes, then we're going to want to add on the frame width. What do we call this? This dot width. So that way we'll shift over one frame to the right for each frame that we're on. Okay, now luckily this math will work out the way it's intended because our first frame will be frame 0. So if we get frame 0, it will kick in a 0 here and that will nullify that out. The next frame, frame 1, will advance us over by one frame. I think I might have got all the pieces, but of course we're coding so things can break. Let's see if it works. Well, of course I loaded it as always. All I did was build this animator. I haven't even used it yet. So okay, so of course it didn't work if I didn't use it yet. So what do we have to do when we use it? Well, now I want to set it up. So here I'm going to say this dot animator, or yeah, this dot animator equals new animator. I'm anticipating an error already, so I'm going to go ahead and do that. Remember, we made our animator class, but we haven't told the index to load it yet. So since Sailor Moon needs the animator, I'll go add the animator in there. So now this won't cause an error. And remember, our animator had a whole bunch going on there. What did it have? Sprite sheet. Okay, in fact, what I'm going to do is I'm just going to cut this, paste it in there, and then I'll go this. Okay, what is my sprite sheet? Well, that's stored in the asset manager. And the asset manager is a global, at least the way I've set it up. And we need this path. So again, I'll just grab that. My X start, that's where I said I was going to put in my zero. And now, in my animator class, I didn't really need to know the width and the height. I just assumed that someone was going to pass it in for me. Now I need to know what it is. Likewise with the frame count, and likewise with the frame duration. So this is where we go back to Paint. And let's zoom in here. And we're going to want to decide, how wide do we think these are? And honestly, you can get really analytical and try and analyze. I'm just usually going to guess. I usually guess, and then I adjust it. And then if it doesn't work, I get frustrated and give up. No, if it doesn't work, then I might come in here and just do the analytical bit. But you see what I'm doing? I'm just grabbing a pixel 52. I like it. 52. Maybe they're 52 wide. Now remember, I anticipate that there's a little bit of extra padding on the front there. So maybe 52 isn't right. Maybe it's 48. 48 kind of sounds right. That's one of those magic numbers, right? But I'm going to go and I'm going to say 52. Okay. Now, what else can I do here is I can grab the height, but I think I planned this one out. When I made these, it was a 516 by 108 pixels. And sure enough, okay, that's pixel 107 because we started on pixel 0. So height, I'm going to say is 108. How many frames? I didn't see. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, was that the last one? Let's try again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That looks right. It's strange. Maybe I did need that first image that I cut off. Hopefully I didn't. Let's try 11. Frame duration. How long does it take you to make a step? I don't know. So let's maybe make this 0.2 seconds. That means the whole animation will take a little bit more than 2 seconds. All right, Sailor Moon. There's not going to be any update for Sailor Moon, at least right now. I'm just leaving her alone. And then we need to replace this draw image because that'll just draw the whole thing with a call to our animator. So this dot animator dot drawframe. So let's just make sure and be careful here. When we call this dot animator dot drawframe, if we go in here, it calls the draw image, but remember it has this prototype. So I'll grab that prototype. So what do we need? The tick. Where does we get the tick from? We get that from the game engine. And that's something that I usually pass in. So I'm going to do a this.game equals game. So I can go this.game.clockTick. And that's where we'll get the tick. That will tell us how long it's been since the last tick, basically. The CTX, that's what we got passed in, so that's good. That's the context. And then the X and the Y, I don't know, where should we put Sailor Moon? Let's put her at 25 at 25. Just give her a little buffer there. Okay, we try and run, and we got ourselves an error. So let's grab the error, let's see, okay. The error I got was, this.game.clockTick. I must have messed that up. And of course, I'm pulling this from my memory. So let's go and see if we can do better. What is it? The game engine. Okay, so I verify here that it is indeed called clockTick. That's what I was looking for. But let's take a closer look at that error. It says cannot read properties of undefined. And it wasn't telling me there was something wrong with clockTick. It's saying when it was trying to load clockTick out of game, it wasn't defined. So that means something went wrong up here. Nothing went wrong up here, actually. I think I found my bug. Maybe you've already found it. But up here, see, here we are it's telling me this is undefined, which means, well, what was passed in probably was also undefined. And I bet you if we go back and we check in our code here, well, that's Sailor Moon. That's where the game is supposed to come in. If we go to the main, Sailor Moon, aha, this.game. Okay, pass that in. All right, so let's be double careful. I called it this.game. There is no this.game here. It's game entry. So, of course, keep typing the wrong thing and giving myself the same error over and over again. Let's try one more time. Hey! Okay, well, so far so good. Not quite there yet. Okay, let's reload this because it obviously, okay, first of all, she moonwalks a bit. I was expecting a bit of a moonwalk. And, well, she should keep walking at least. It will be helpful for debugging if she keeps walking. So I want her to keep walking. So to do that, I need to go into my animator. And the problem is when my current frame runs off the end of the total time, she doesn't draw anything because the current frame that pops up is too big. And so when we do this draw image call, it draws nothing. So instead, what I need to do here is a little test. If this dot elapsed time is greater than this dot total time, this dot elapsed time minus equals this dot total time. And that's like doing a mod operation kind of. It's just saying if you've overlapped it, let's just minus off the total time, and that will wrap us around back to the beginning. We should now have, okay, she is doing it, but it looks like she's flickering a little bit, maybe. So there might be a dropped frame. If so, we can analyze that too. But first, now I want to deal with her moonwalking. Okay, moonwalking. So why is she moonwalking? The reason she's moonwalking, let's go back to the actual animation again, because we'll notice she's moving backwards. Okay, now I'm not moving the frame where I'm drawing it at all. Just, it's sort of like on the old TV, sort of, you know, when your cathode ray tube would go off. It's just kind of flickering back and forth to from the left to the right. And what we need to do here is we need to adjust those parameters we put. Remember when we guessed 52, it's that 52 that I think is off. So one thing that I want to do here is, well, let's see. Let's go back and to the code where we put in that 52. Remember I said maybe it's 48. That was another guess. That's just 4 different. That's going to change it. That's going to make it shorter. It's going to make it shorter. Let's see if that's right. Let's see if I can reason about this. Usually when you're looking at the animation, you can tell. Because she's moving backwards, that means we cut off too much of the next frame when we advanced, okay? Because instead of starting the next frame where we were supposed to, we started it too far to the right. That makes her seem like she's moving backwards. So what I've done is I've taken that 52, which maybe was 52 pixels, that was maybe 4 too many. I'm gonna change it to 48, and we see that her sliding back is not as bad. She's still sliding back, but this means we're in the right direction. And usually here, what I start doing is a binary search. So I might say, now I'm going to guess 44. Oh, now she's sliding forward a little bit. Oh, it's a little bit hard to tell because of that, because she's not centered in it. So even though I want to keep doing a binary search and fix that, maybe I'll do a 46 now because that seems like the right direction. Now it seems like part of the problem is, well, let's run it one more time. Okay, now she almost looks like she's right in the right spot for walking. But the problem is we're just offset a little bit. I might not be right on the pixels exactly yet, but I need to shift. You see how there's that little bit of toe showing up? We don't want that toe showing up. That means we need to move everything, all the frames, to the right. And that's because, remember, I left a little bit of white space on the front there. I didn't want to cut off the white space on the front here in case it was needed in the animation. So I left a little extra. I left a little on the back just in case too, to make the math hopefully work out right. But it turns out I left too much. So let's see, X, Y, which one we want to move X. Let's say, I'm going to guess I had 4 too many pixels. Again, I'm just guessing. So let's go back to Sailor Moon. pretty good, pretty good. She's still got that little toe hanging off. So maybe it was, I don't know, 6 pixels? Oh, and now her hair is coming in the back. Okay, so now we're getting into a tighter, more finicky problem. But I think I'm going to move. Remember we said we're going to binary search, so let's binary search. No hair from the back. That's good to see. But still this little bit of shadow, little bit of shadow. Now, here's where you might be thinking, okay, what do we do now? Well, the truth is, it's possible that we're not just on integer values here. So if I'm remembering my binary search right, the next thing I should try is 5.5. Okay, now if you can see, there's a little hair here and there's a little sliver here, and that's telling me that no matter what I do here, there's no way that I'm going to be able to fix this. Well, that's not true. There might be a little way to fix this if I keep trying. So one thing I'm going to do to try and help us with the debugging, since it's a little hard to tell, is I'm going to make her twice as big. I'm going to add this one line in that my student Parker told me will help it make it a little bit clearer when we animate it. And with that, it makes it a little bit easier to see. Actually, this is good. I'm glad I placed that on, because earlier I was getting a little artifact over here of her hair, but I think we might see it getting cut off there. Yeah, there's a little bit where one frame is being cut off. So it turns out that it's probably the case that I shaved off the wrong amount over here on the left, and maybe I can adjust that a little bit. So I'm gonna try and reload it back into Paint 3D, and then I will go for a crop, and let's see. It's allowing me to crop off 1 or 2 pixels at a time. So I cropped off, I'm going to crop off 4. So I am going to crop off 1 more pixel on that side. What I'm hoping I'm going to be able to avoid is moving these images around, but I might have to move them around. So again, I'll change this one to a 0. Another trick I like to use when I'm trying to debug animations like this is I slow it down. That way it's a little bit easier to count what frame it is and see which frame is causing the error. So we have, let's restart so we can, that's still a little fast, so maybe I'm going to slow it down a bit more. 1, 2, 3, it's the 3rd frame, 4, 5, 6, 7, 8, 9, 10, 11, and the 11th frame. That's a weird combo. So when I'm saying that, on the 11th frame there, we just missed it. Oh, well, she had it there too. Normally she's got this dark band on the end of her hair, and she loses it there, but then there again. Okay, it looks like on frame 11 she actually doesn't have it. Now I'm getting suspicious about where I got this from. Whoever chopped this off, maybe that's supposed to be there. Oh no. Is this the same image? This one and this one? No, those are not the same image. All right, time to get a little bit more analytical. Let's see, what was the numbers we were working with here? 46. Let's see here. We said we have 46 pixels times 11 frames would be 506 pixels. According to this, we are 511 pixels. that would make us 506 pixels. The problem is on this frame here, we're getting these 3 pixels, 2 pixels wide, I should say, are overlapping. So one fix I'm considering, and I don't know if this is the best one, is I want to move this frame 2 pixels to the left. Okay, I think that was 2 back. I moved her 1 down and then I moved her 1 back up again. Hopefully that's right. You can see her shadow, you know, goes up and down a little bit. It's all right. You just want to make it look right when you finally animate it. So. Well, now it's getting a little bit hard to tell. But we got rid of that little artifact, so there's no more little clipping. And all I had to do was edit the sprite sheet ever so slightly. And now, I think the only other thing I want to do to make her kind of look like she's actually walking instead of moonwalking is let's move her to the right a little bit. So let's do, let's give her a speed. That's usually the right way to do it. I'm going to call it this dot speed equals 25. We'll make it 25 for now. And then what I'm going to do is I'm going to say this dot x. I don't even have a this dot x, so if she's going to move, she needs a this dot x. I will say is 0, and this dot y is also 0. And then in my update, I'm going to move my x. This dot x plus equals. We're going to just add to it this dot speed. That's going to be the number of pixels per second, so I'm going to multiply that by this dot game dot clock tick, which will tell me how many seconds have passed since the last time we had an update. Because I didn't add this dot x here and this dot y here. That makes sense if you don't actually draw them where they are. So let's try one more time. Boom, okay. Now, everything's going really slow because we have the animation on slow and we have the movement on slow. But maybe I should speed them both up. So let's, we're on 1 second. Let's go back to 0.2. Let's just see what that looks like. Well, we probably need to speed up past 25. So let's go up to, ooh, not 1,000, 100 pixels per second. It's still kind of slow, I guess. It's looking all right. Now, what I've been looking at here is I'm looking at her feet. They're still kind of sliding back like there's a little bit of moonwalk going on there. And now this is about the timing of the animation with how fast she's moving. And again, this is something you can balance a lot, but you don't really need to. Usually it looks good enough. But I think she would need, let's see, if it's sliding backwards. Yeah, I think it's gonna be impossible to eliminate it altogether. But let's maybe speed her up and see what that does. Now I'm also getting bored of reloading every time she gets off the end of the screen. So why don't we do this? If this dot x is greater than what's the width? Why don't we just go look it up and hard code it? It is 1024. So if the x is greater than 1024, let's do this dot x equals 0. Just push her back to the beginning when she's done. Now she's going a little bit faster. Starting to look like maybe that's the speed she's supposed to walk. It looks like there's still a little jerkiness in it, and that might mean we need to move a few more of those frames around. But again, at this point, I'd say I'm pretty happy with where I got her. Maybe let's speed her up one more time. Let's make her 250. Yeah, all right. I can't tell if that's better or worse. But I'm pretty happy with what we got accomplished here. So hopefully that'll help you get started on animating your own sprite sheets or any random ones you find online like this. And if you are making your own ones, you won't have to worry about the sliding and the moonwalking and the shifting things around. Hopefully you'll make it right the first time. All right, well, thanks a lot for watching, and we'll see you in that next video.